Hi, in this video we're going to be discussing the different intervals as they relate to key features of graphs. So the first key feature that we're going to be discussing is going to be the turning points. So most of the time we don't have a difficult time identifying the turning points themselves. Sorry for the handwriting. The turning points themselves, it's more of the notation that we're struggling with, but in this case we are just going to talk about turning points to look at the different intervals. So when we think about turning points, it's where the graph is changing. So if we think from left to right here, we're going to start all the way on the left that we have. As we come down, we're going to notice the first turning point is right over here because the graph goes from a decreasing up to increasing, and right around here would be considered a turning point. So we're going to put a dot right there on that turning point. And as we move forward through the graph, it's decreasing, and then it turns point right here to increasing, back down to decreasing right here. So this is considered another turning point. So we're going to mark that spot as well. And we have two turning points. The notation isn't too difficult for turning points. It's just what you learned back in middle school. You were just identifying the ordered pair. So the first turning point here, we are going to approximate as being -2, -3. And the second turning point is going to be this one up here, which looks like it's around, we're just going to call that 4, 3. So 4 is our x value, 3 is our y value. This is important to notice because in the next screen we're going to be talking about, actually we can just do it on this screen I think. We're going to be focusing on not turning points, but increasing intervals and decreasing intervals. So for a conversation, or for a notation, we're just going to be focusing on the increasing interval, but it's the exact opposite for, or exact same for decreasing. We're just talking about a different point in the graph. So if we go back to discussing how we start on the left side of our x value, so our x value is it's far enough negative, as we travel to the right, notice that this graph is decreasing. It has a decreasing slope, but we're looking for increasing. So we don't want the decreasing portion. We want to somehow identify just this part of the graph where the slope is increasing. So we only want x values that range from -2 all the way to our x value of 4 right here. So if you can think to yourself, we only want to represent this portion of the graph, we have to look at our x values. So we need to note from -2 to +4 is the interval that we're talking about. And remember that an interval is just a part of the graph. So one way to write this is an interval notation when the x value goes from -2 up to a value of 4. And you may notice the use of the parentheses. That means that those values are not included. Okay, they are not included. And that's because if you look at this specific value right here, we're not increasing nor are we decreasing at that very point. It's like it's level, and we're going to get into rate of change in our next unit, but this value of 4 is not included, therefore this is a parentheses instead of a bracket. Mostly so far we've focused on inequalities, so we want an x value that is going to be this direction or larger than this turning point. So we want to say x has to be larger than -2, so that'll look like this. -2, and x is larger than that. If you prefer to write it this way, that's acceptable as well. But at the same time, we also need to write about how our x value has to be less than this. And remember, we want to be right in this area right here is what the x value we want to represent. So far we're saying we need to go to the right, but we haven't said anything about how we need to go, our x value needs to go to the left of the +4. So in order to show that, our x value has to be less than an x value of 4. Once again, our x value is 4, we want it to be less than, so somewhere in here. You can see that the x is kind of sandwiched in between -2 and +4 because of -2, +4. That's the x value that we want for our increasing interval. In order to finish up this bottom inequality, it's going to look a little bit backwards because our larger number is in fact on the left. And that's how we identify the increasing interval for this graph, this polynomial. If we were to do the decreasing interval, you'll notice our x value would be everything except for this range right here. This is the increasing interval. So if we wanted to show the decreasing interval, we would want to identify this interval right here, or this section of the graph. This is decreasing, and this is decreasing. So we would need to somehow identify these two sections of the graph if we were to be doing decreasing instead of increasing. And we'll work on the notation for that on the next slide. In this section of the video, we're going to be talking about the intervals that identify the positive and negative intervals. So, at first we need to remember what exactly we're talking about with positive and negative intervals. So if we have our marker here, let's say we're talking about the positive interval first. And this might be a new term to you. Let's remember that interval means a section of the graph. And I apologize for the writing on here, it's not very easy. So positive interval is when our y value is positive up here. So it's all of the stuff up here where our y value is positive, but it will not go down here. This is not the positive interval. This is the positive interval above the x-axis. Okay, so when we're talking about the positive interval, we want to talk about the part of the graph that is above the x-axis. So this section right here, and this section right here. So it's actually going to be two different pieces. This one is positive interval, and this is a positive interval. So in order to write the interval, we have to identify the part we're referring to. So you'll notice as we start from the left, and with intervals, we always talk about our x values. Well, we typically talk about our x values. So with a positive interval, we want to go from this point all the way down to infinity. It's going to go on forever and ever. We can get -5 is a positive interval, -6 is a positive interval, -100 is a positive interval. So we can identify that x has to be smaller than everything up until this very point right here is where it becomes neutral. It's not positive or negative interval. So this point right here is what we're looking for, because anything this direction is positive. So you'll notice that this is the 1 to -3. So x has to be smaller than -3, once again, because anything in this direction is going to be a positive y value. So this section of our interval refers to that portion of our graph. Now we need to move to the other section and talk about this part of our graph, this interval that is positive. So we look for the intercepts here to identify what we're talking about. So we're going to go from an x value of 0 up until an x value of 5. So we want to represent from 0 to 5 for our positive interval. So x has to be larger than 0. And that's because whereas x is 0, we want it to be larger than that value. But it has to be, x has to be less than 5. So x has to be less than 5. And this part of our notation, this part of the notation right here, refers to this section of our graph. Notice it's all above the x-axis, which is our positive interval. If we switch gears a little bit, let's now talk about the negative interval. Okay, so I'm going to draw a line separating, and for our negative interval, it's the same process, but we're talking about a different part of the graph, so we're going to have a different interval. Our negative interval is going to be when our y value is negative down here. So whenever our y value, remember this is our y, is negative, it's going to be down here for our negative interval. And so we've got this part of the graph for a negative interval, and we have this part of the graph for a negative interval. So first, we're going to go left to right. We're going to talk about this point for our x value, all the way up until this point. So an x value of -3 up until 0. So x has to be larger than -3, and it has to be less than, so larger than -3 is this way, but it has to be less than 0. So that refers to this portion of our graph, and we're all done with it. This is known as a compound inequality. Notice there are two inequality symbols. So it is compound because we have two endpoints. Here's one, and here's one for our interval. Moving forward, we have our last section of the graph down here is our negative interval. And we need to show that by saying x cannot be 5, but it can be anything larger than 5. Our x value is going to trail off to the right here forever. So all I need to say is that x has to be greater than 5. If you prefer, you can write it this way. But most students actually prefer to write it this way. X is larger than 5. So these two refer to the negative intervals, and these two inequalities refer to the positive intervals. Hopefully that helps.